Good morning, good evening, good night, good wherever you are, whatever your time is. Crypto is up. In fact, I'm making a profit on both my investments right now. One is Monero, the other is Luna 2. And both are in the plus, meaning I have a stop loss in place, which means if I do nothing, I will at least get my money back. If it raises a little more, then I will actually make profit. And this is all in the course of like a few days. Luna, I think 2 days, and I already make some profit. On Luna 2 you actually get dividend. They gave me 1% more Luna 2 after another day, which a little bit seems to me like maybe it's a gift to persuade you, like a trick. You know, the question is whether all these coins are Ponzi schemes or not. But it doesn't really matter if you do short-term trading. I mean, what do I care if it fails long-term when I only work with it, only hold it short-term? So yeah, we could continue with recognizing some webcam stuff, but I think today I want to do something different. I actually want to recognize this image, recognize the stock chart as a preparation for a trading bot, right? If my trading bot can directly look at my windows, that seems like the easiest way to make a trading bot. Otherwise I would have to get into APIs. APIs are stupid, annoying work to program against. They may cost extra money, etc., etc. If I can just use windows like this one, that's the easiest way, right? So I want to find this line actually, simply. That's the point. And I'm looking for the right window. Where's my window? Here. So I made a screenshot here of this very thing. And along the way I also want to improve the user interface here, because it's not where I want it to be yet. For example, here, if you click zoom to window again, first of all it's supposed to zoom automatically, which it doesn't really do all the time. That's annoying. And if I click here, it will remove the check mark, but I wanted to keep the check mark and do the zoom. Things like that are stuff that really should be improved. Making a nice and really polished user interface is a lot of work. That's generally the truth. But we only have to do it once, and then we have our amazing user interface. Alright, so yeah, image surface. Let's check out that one first. I got my new quiet keyboard. If I don't hammer it too much, it should be very nice and quiet. Quiet mouse is still to come. Maybe I can threaten the mouse into being quiet, but I don't think that's gonna work. Yeah, we also can have this delay thing in the webcam. I have to figure that out too. Okay, step by step. Zoom to window. Why is it grayed out? Oh, here, this is the one. Checkbox menu item. Basically, you don't want this to ever turn off, actually. If you click here, it always turns on. If you want to turn this off, you click somewhere else, like zoom 100%. That should turn it off. Which I guess it does. Zoom reset. Set zoom. Yes, this resets this variable, that's fine. And there's another function that sets the zoom but does not reset this. So actually we're almost there. We just have to teach this object to do what? To react differently when clicked. Bind to component. Is there a way to change what happens when I click it? I guess it has an action. An action event. Action listener. It does have an action listener. We can do a little experiment for sure. In our cool scripting language. So we have some UI playground projects. Here it is. So box menu item. Click me. Oh, here's our first lambda. Let's say this is always true because we always want it to be checked. And here is our second lambda, which is changing the value. Method not found. Oh. I should learn my own scripting language. Click me, there we go. Okay, so far so good. Change false, change true. That is happening, that's good. And we add the action listener. Add action listener. Print action. Okay, so we get the action event. After that we get it. Yeah, okay, this happens first and then the change happens. Which is slightly unfortunate because I was hoping it happens the other way around. Listeners that you add last are called first. That's how it works in Java. So let's say we add the listener first, the action listener. Then I think we could get it over there. Yeah, basically we just make a way simpler menu item. I mean, the point is always supposed to be checked. So we just do this. And we set it initially. Okay. Oh, it wants some kind of listener that I don't need at this point. Okay. Okay, it's deselecting, but I can now in my action listener undo that. Value is checked. Menu item. Value false, value true. Okay. If not is checked, then set checked. No, yes, set checked. True. Let's try. Okay, it always stays this way. And we get our action that we can react upon. Very nice. So we call this new thing always checked. Always checked. Checkbox menu item. Maybe a little shorter. Always check the menu item. That's okay. So we have a text and we have an action. Still getting used to the new keyboard. True. Yeah. In fact, I could use this function here already. Yeah, okay, sure, I could do that. Checked. And if not checked, set checked. True. Oh, but I'm referencing the menu item before I create it. That's not going to work. Chicken and egg problem. So gotta do it more manually. There we go. Add action listener. Check me. And call our action. There. That's correct. Compiler is always right. And now we put this in here. Oh, but we don't want it to be checked always necessarily. Okay, I did a slight miscalculation. It is possible to uncheck it just from somewhere else. So well, even the simple things can be difficult in programming, so let's keep thinking. I wanted to bind to a variable actually. Checkbox variable. Yeah, complexity lurking everywhere. Yeah, I've already searched that menu. Huh. Okay, I don't need to dynamically change the checkbox because it's only shown when you open this pop-up menu. That makes things a lot easier. So this menu is normally not shown, so it's okay to get the value when I show the menu. Makes it a little easier. Check on click. Greatest naming ever, definitely. Okay, so we have our checkbox menu item, and upon showing it, we invoke a function. Yes. Like this. And we have our action listener like before. Okay. So this part stays the same. And then we have our action. Which triggers the auto zoom. Yeah, I think that could work. I should try this before actually going all in. It's compiling. On this poor overloaded ThinkPad. It's really quite overloaded. Wow. Exciting. Here's our image surface. Okay, it doesn't really show an image. Here. Okay, zoom to window. It has zoomed. That's nice. It doesn't zoom immediately. Start working on that. But now if I go here. Oh, why does it not check this? That's crazy. That is actually strange. What if we do this here too? Not working as I expected. Strange, strange. Zoom to window. Okay, now it's checked, that's good. It doesn't redo the other zoom, but now it does it. Okay, that's good enough for me. Let's bake it in and be happy. Compile main library. Boom, okay, one thing done. Back to the interesting stuff. Here's our screenshot to recognize. What do? We make a network, a recognition network. Recognize start chart. And right away, let's improve the UI too. This distance should definitely be full. This is the length of, this is how far apart parts can be in order for them to connect to each other. We should put that on full by definition, by default. So it's in J, this one, this class here. Or actually no, it's in the backend. Yes, magnetic distance. Default 100. Auto calculate. Yeah, why not set this to true? By default also. Very nice. Auto update. So now if I create a new network, I will get this check mark and this 100 already. That's nice. New node. And I wanted to change a few things also, because here if you go in the negative, meaning above the boundary, you can never really move it back down again, I think. This should also be prohibited. It's in the component dragger there. Update position. So this one would have like a limit. Yeah, let's say by default we say no less than 0, 0. Safety. Okay. And I guess it's in the library. No, it's not in the library. It's in the main program, so we can quickly recompile it. That's nice. So in a few seconds, we should be able to test the change. Let's try. Huh. GUI frozen. I just saw an error message, but I clicked on OK, so that's not so cool. What is happening? Is there another error message? I don't see. Yeah, it is. There's another one. Okay. Let's see where it is displayed and get rid of that. Calculation step. Yeah, right. So it is here. Calculation step. Is this function showing the message box? So it's triggering a calculation in the background, but if the calculation goes wrong, it shows a message box for the user to confirm with OK. So at that moment, it freezes the whole user interface, which is completely not OK. So where is the message box happening? Here. All right, okay. Yeah, no, message box is definitely the wrong choice here. We can use info box, which does not require user confirmation. It just pops up in the corner. So that's a lot better. Okay, another problem fixed. Let's rebuild. Right. Yeah, no, you cannot move it beyond the corner. The other direction is fine because it will create roll bars, scroll bars automatically. Good, good. We should do the same thing for the resize dragger. In fact, yes, this one. We have points A and B, so it's only relevant when we drag left or up. Yeah, just here. Max 0. Bam. It's also in the main program, that's great. So we can update it quickly. Okay. So, I guess when I create a node, the code should be visible right away. Is that doable? Collapsible panel. We would have to put it in the back end. Meaning in this class. Code visible. Is code panel visible in GUI? And do we actually put it true? I guess we do. Network element, and here we have to combine those two. I did something similar in exactly this thing here. It remembers whether you have the network list open or closed, which should be like the same thing. Oh, I'm persisting the whole panel. That's kind of crazy stuff. Yeah, it also has the split point, like how big each of the panels are. Yeah, you can persist the whole panel. Is that what I want? No, I don't think so, actually. No. No. I just want the visibility of the code to be persisted. So we can bind variables to each other. How does that work again? Bind var. I think link variables. Link vars. Okay. Let me make a synonym of this. Synonym of link vars is bind var to var. Bind var to var. Element dot code visible as a variable, and collapsible panel dot expanded, right? Collapsible panel. Yes, expanded. Or expanded. and it looks good to me. Let's check it out. Next we should bring down the auto calculate delay, which is set to 1 second per node right now. Here. Usually we want 0. Just instant calculation, right? So code is visible. If we close and open again, it's visible. That's cool. Let's say we hide it. And it's hidden. Oh, that's great. Yeah, it's complaining that it cannot compile this code. I mean, this code is simply empty. Is that uncompilable? No. Empty code should be compilable. It is compilable. What's the error? Network element dot compile, not compile, compile. Okay, if there's like there's empty code and there's null code, which is, I mean, it's actually the same, isn't it? So let's say we just treat null code as empty code. That sounds pretty reasonable. Null. So compile empty code, that's fine. Yeah, this should get rid of that particular error. L'erreur. Set an erreur. Perfect French. Or not. Okay, no more error message. Type null, that's fine. Empty code evaluates to null, that's perfect. And now I want to just write the minimal amount of code to get this node working. So what I want is actually just get a gallery image. This one here. ID 8. Get gallery image 8. Get image. Error. And definitely here I want to show the actual error. So that's another thing to improve. Okay, network element. Error. Okay. Label dirty. Yeah, we just make a listener to, I mean, click listener or menu maybe. Component, pop-up menu item, label dirty. I want this to only appear when there actually is an error, but whatever. Otherwise it just does nothing, it doesn't matter. Show error, I guess. Value has error. My value. value. Okay. Huh. It does not seem to store the error. That we should change. Has error. Yeah, how about just error? And it's probably a throwable. Yeah, why not? We can keep the has error method around to not break existing code. It's simply error not null. There, and has error, okay. Show error. My value error. Error frame, do I have something like that? I guess I do. Yeah, good enough. How about we are really smart, and if there's no error, we just show nothing. So we can simply say show error frame even if there's no error. Looks good to me, but who knows if it works. Error. Show error. There we go. Field get image not found in buffer image. Ah, okay. So get gallery image actually gives us the image itself already, not the database thing. Okay, cool. Wow, nice. Okay, there's our image. And how do we find this chart line here? In the second step, we will look at the numbers and the horizontal axis, like the times. But the most important thing is, well, they're all important. The first step is to find this green line here. And yeah, this node needs an output port, which I want to create automatically now, simply from the return type. It's basically all the information we need. Usually I had to write some more code to create this output port, but that's what I want to automate also. Configure node. And it probably should go into the backend, I guess. Here we have our port definitions. And yeah, however, this one doesn't know its instance. So we need kind of a front-end thing, actually. No, not really, actually. Okay, let's say auto create output port, and we get our instance. We get our instance here. Yes. Let's say I remove output ports. Oh, I don't even need this change method anymore. That should be automatical. Automatic. Right. Remove output ports. For all ports which are output ports, p.delete, and then we get the type of what was calculated, which is just my value. What's that? Okay. Yeah, that's the one we want here. My value dot object. Class. If there's no object yet, we just say it's the type object with capital O. Type. And we say add output port. We call it just output. Position is any random position. Let's say on the right. And the type is the type we just inferred. Yep. And for now we could make it a menu item here until we actually automate it completely. Oops. Here, there's a menu somewhere. Where is the menu though? Oh, it's got a pop down button, not the menu. Create output port. Do I have to do anything special, or do I just call? Oh, let's make a function out of it. Auto create output port. Element dot same thing, and get this instance object. And let's try. When I get another monitor, I can get rid of the last hissing noise in the background. That's just my notebook fan. Then we should have a very quiet setup. For filter, okay. 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 I'm so pale. The sun is shining. Okay. Great output port. Wow, there's our output port. That's very nice. If I do it again, it deleted it and recreated it, so it doesn't make any difference. Something that would be really nice is if I could just click here and drag the port around. It's yeah, it's something we should have, so let's do it. Let's drag the port around. Network port. Where are all the ports? Oh, okay, different class. Here. So basically it's just a dragger, but it's a dragger with a special mode because it should only drag this around the whole edge here. So component dragger, not a long class, so should be fairly easy to modify. Like here, where we calculate the new position. Can make it swappable. Point or X and Y. Always these little decisions. It's basically completely equivalent. Yeah, why not X and Y? Who cares? Okay. Yes. So here's our part visualization. And after we initialize it, we give it a dragger, grab, drag, whatever, component dragger. Component mouse event. do I use it? Okay, I have to handle the event myself. Okay, fair enough. One mouse down. This. I drag this around. That we don't actually need, I guess. Although, I mean, why not? And start, and then we modify it accordingly. Update position. Call the normal thing and update our position in the backend. Oh yeah, no, I have to actually. I don't even need this part, I think. It should move automatically, right? So port set position or something here. Position. Yes, we calculate the position. So if I have a random location, mouse location, how do I know which edge it is closest to? Basically, I have to look at the diagonal, right? If I'm somewhere in here, I choose the right edge. If I'm somewhere here, I choose the left edge. Here I choose the top. Do I have like a distance to line? I guess I have this. Distance point to line segment. Interesting. Yeah, it's overkill, but doesn't matter. Okay, sure. So we have element parent. Yeah. Okay. Get bounds element. So that's our top edge. Distance to top. Okay, first we put this thing in a point variable. There. The bottom. It's the same thing on the bottom. The left is this thing here, and the right is this. So now we take the shortest one, closest distance. Our minimum. So if the minimum is the top, then we are at the top. Then position, let's shorten this, position Y is 0, position X is we need this relative. We can be smart about it. So we need this relative position of 0 to 1 and 0 to 1. So we have x minus r dot x divided by the width, and we have this minus this divided by the height. And actually now we only have to reset some of the values. Yeah, this is. So we snap to the edges here. And the last one we can just assume x1, x0, and that's that. And if I'm right, it's going to work. If I'm not, it's not. Okay, bracket problem. Oh, here, 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 here. Nope. No, that's not right. Wait. Oh, I just, okay. Just left some random crap in there. That looks better. Come on, hurry up. Ah. Okay. Double min. Just a tiny change. There. And we need this. You'll see in a moment, I think, what the problem is. You can go out of bounds, basically. Let's just check it out before fixing it. Let's just compile. So the point is we wanted to move this port thing around here. Just with our mouse. And we can move it, see? But we can move it like outside of, like move it here. So now our port is like floating around far away from the network element. So that's the last thing we have to fix, and then I think we're good. Would you look at that, all this crazy code I just made? That actually kind of works. Left works, bottom works, that's cool. Just have to limit the value. Yeah, clamp 0 to 1. That should be our fix. Cool, I love this. Keep caffeinated. Always important. It doesn't seem to actually persist the change properly. Let's check. Port. It should though, right? This will trigger the change here. Yeah, no, it actually we need to connect change events here to change events in the network element. And it's a little bit tricky. Okay, so one time we have to do this is when we actually add a port programmatically. Yeah, like this. Then we would actually do this on change. And the other case is when we load the whole thing from the database. How did that work again? On load or something? Wait, I forgot. Done loading. I should make an interface for that one. Oh, I forgot to renew. I forgot to renew the certificates. One of the certificates on the server. Should I do this right now? No, do it later. It's not the most important domain, but it should still be fixed. Could lead to some other problems. Okay, we have this interface now. And when is it called? It's called after all the values are set for the object. Right? Yes. So we can simply do it in the port object. Is I unstructured. Done loading and connect the change events. Element on change element change. Any problem with that? No, I don't think so. Hey, where's my chat? Oh, I have to keep this window open. Okay. User interface is definitely improving. Okay, so now if I move this around, oh, it's kind of, why is that? After a moment it's losing the event. It may be that it's recreating the port visualization. I think that could be a thing, actually. Yeah, visualize ports. Yeah, we have to keep the object, keep the visualization around, not recreate it every time. Yes, we simply call the update thing. Yes, 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 yes. Yes, and yes. Yes, okay. Visualize ports. Okay. So there's three cases. There's update, there's created, and there's port removed. Okay. So we have to make like a map, I guess. Visualizations, which we gather. not ports, port. Port, port, I guess. Port. Visualizations, port, and ports. So now we know what has been visualized. Then yeah, we go through all the elements. All the ports in the elements, and we check our map. And if it's already there, we just update it. Else we create a new port. That's fine, and the last thing is we have to do is remove ports that are not there anymore. Could do like a funny thing, just remove it from the map here. No, wait, yes, yeah, sure, why not? Update and visualizations, remove this one. So all the visualizations that remain are actually to be removed. I think it's correct. Try it out. So here we could recognize the white and the green area, or we could look specifically for the line in between. Or we do all three of these to have them verify each other. Huh? Ah, okay. Little JavaX weakness. Nothing to worry about. I'm getting very hungry. Got this for free when I ordered some pizza. Too much sugar, but whatever. So, hey, it works. Should have a remove port function here. Let's put that one in. Delete ports. Yep, that was quick. Mm-hmm. Deport. Oh yes. Very nice. Very, very nice. Okay, cool. So we have an image supplied through this output port. Next thing, we do something with the image. We can do our normal thing, which is scale and posterize. Why does bring to front not work? I'm so angry here. It should, if I click node, it should bring the node to the front. And it's just not doing that. It should be done right here. Start, bring to front. And it's doing this, but only later. I'm completely confused here. Like here, when I click here, it doesn't bring to front. Boom. When I click here and move just one pixel, it brings it to the front. But why not in the first place? Because mouse dragged, update position. I'm not doing it here, I'm doing it here in the start method. I even print this to the log. So here, let's check the log. So I click here, it says bringing to front. And I move it. Do I have to like repaint the thing? Oh, I have to repaint. Oh, holy mackerel. Yeah, okay, that's okay, sure. Component to front. Repaint, get parent, component. I think that could be it actually. This one was bothering me, it was so nuts. Yeah, simple repaint, of course. That's it. Let's see how Monero is doing. Still very strong. Very strong indeed. Okay, let's try again. Yeah! Wow! Boom! That was actually a simple solution. Just had to figure it out. Yes, good. Good. Okay, so here we have an input buffered image. And let's simplify this function also. What if I just say posterize? No scale, just posterize. Oops. Oh, that's the same function. I think we're wasting some time if we are not scaling down. It's making an integral image anyway. That should be optimized. Integral images are for scaling down, but if we don't scale down, we don't need that. Posterize. this BW image. Can I write this, etc.? I cannot, but I could put that in my language. That's the cool thing in JavaX, you can just say type and etc. So it will know some standard conversions and create a second method that does these conversions. And it's defined deep within the transpiler. Namely here, it's a bit unelegant, but so if the main type is, for example, the main type is black white image, my alt is buffered image. So I automatically convert the buffered image to black and white image. That's nice, and I have to recompile my compiler, which is pretty fast, thankfully. Then we can compile this. See, that was it already. Now my language has been extended. And if we click here, we see we have two method signatures. The original one here, and the one with buffered image, which does the automatic conversion. That's actually super neat. Mega neat, actually. Mega ultra neat. Even. So posterize image, and I just put in the number of, the brightness levels, number of colors. Let's say 8. And this, and now I want these ports to be made automatically. Not only the output port as before, but okay. Which also has the wrong type because it didn't really calculate yet. Oops. Aha. I delete the port. Let's see why it doesn't update. Delete. Oh, I didn't change something. My bad. Ports.add has to become add port, except here. Add port, add port. Yes, and boom. And now we have to create input ports automatically, for example, from this here. Yes, sure. So you can actually just combine this into like auto create ports, I guess. Oh, maybe let's do 2 steps. Create input ports. And there we need, we don't even need the value, we just need the object itself. Let's check if the other thing works now. Create output port, okay. Delete port, yes. Okay. Create input ports, and we need the compiled script. Okay, we do need a parameter, which is this one. Our general utils. Compile. And from the compile result we get okay, let's check how that worked. Oh, the parameters are not specifically stored, I think, but they should be. Yeah, in the parsed script we should store the parameters, you know, declared with this like param name type. Okay, let's add that. Test that params are stored in parsed script. Left arrow parse, left arrow parse verbose or something. Skip the params. Is X. Java class. Java class, and it's gonna be int dot class, and we need to declare this. Map as descriptor. Yes, there. And now we want to see the test fail as per tradition. Make test, see test fail, fix implementation. TDD, test driven development. That's going to take a bit. Yes, this is the error we wanted to see. Sometimes errors are a good thing. Create or put. What's that called again? Put or create. Maybe we want to preserve the order of the parameters. Like this. There. I think that was actually the whole fix. So now we can access these parameters, and from the parameter we make an input port for the element. Script. Now we go through the parameters. There's building script and there's script. Yeah, but script is already set, so we can just use that one. Yes. That should actually work. Okay. Name, type. So I say, okay, remove input ports. See? Oh, we have an okay. All the tests work, and the new test also works. I like this new keyboard. It's very easy to type, and it's quiet. Perfect. Anti-filter. So add input port. Name is name, and position is, yeah, what is the position? We position them all on the left, I guess. Just to have any kind of default. N is length of params on the left, and some vertical position that we're gonna figure out. And we get the Java class. And if there's nothing, we say it's object. Y is if there's only one input port, it should go in the middle. If there are two, they should go like, I guess, like a third and 2/3. So we have n+1 is our denominator. Right. And Numerator is starting at 1. I think that should give us a decent layout there. Okay, all that remains is to test. Java is strict with its syntax. You could make the point that this is clear code. I mean, just repeat the type needlessly, but it's pretty clear what it's doing. So, but no, compilers are not like that. Compilers have rules, and the rules are followed at all times. Okay, so let's try to make some input parts. Oh, that worked well. Nice, actually. So I do the connection now. After it connects, it should definitely recalculate this one, because it just received new input. It's absolutely a trigger to recalculate. Yeah, let's put that in. So our magnetic connections happen in the network. Here. So basically when we connect the cable, it should turn the node dirty. Yeah, there's this distinction between the node, which is like the blueprint, and the instance for the calculation, and this node doesn't know its instance actually. So, and the instance gets dirty, not the node itself. I mean, but we can just, let's see. Oh wait, but the instance knows the network, so the instance could listen in and invalidate itself automatically. Invalidate node. Right. Yeah, let's okay, we can do something else. We do the magnetic connections, we just return the new connections that we made. That sounds reasonable. Cable. Yeah, return new connections made. And yes, that's the type, network cable. Right. New this, new cables. New cables, add cable, and return new cables. And then the caller, which is the front end, can invalidate the nodes. That's a reasonable logic. No cables. For all cables. We take the to node, which is the dependent node, and we invalidate node. Yeah, exactly. Invalidate node instance dot invalidate node cable 2, and the final repaint is not hurting anyone. Should not be necessary, I guess, but oh yeah, but maybe it is. Okay, so let's disconnect again here so we can test. Does it auto update? I don't know. It's even higher now. I'm really making profit here. I bought for 170. Wow, man. And the fees are lower than I thought. Fees with Kraken, I think. I was calculating with 3% for buying plus selling, which is like the worst case, but I think in reality they were way lower. I saw something like 0.5%. If that's the case, this is even more profitable, even less risky. It's pretty amazing, actually. I actually believe you can manage your risk. It's not zero risk, but you can have like zero risk of losing everything. I guess that's something you can do. It's interesting stuff. Instance, where's my instance? Okay, it's not instance, it's the network instance. Sure. Network instance. I still think making a good product is the best way to make money, because then you actually help people. If you do only trading, you are just taking money from someone who is less fortunate at trading, I guess. You know. Yeah. What is trading? Is trading evil? Is it a necessary evil? Is it good? Fundamental questions right there. Invalidate node, blah 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 blah. Okay. Almost there. You have to invalidate the element that's connected to the port. I think this should compile now, and we should get our automatic dirtification. So many bugs fixed today and features implemented. I like it. Okay, let's do the connection. Right now this node is clean. It should turn to dirty when I do this. It does. It has an error. That's okay. It's expectable. It's new code. It's in the utilities. So let's compile the whole thing. Why not? It's nice and compact code. This is what I want to do. I just write the actual computation here, and all the ports are made automatically, and all the data flow is handled automatically, etc., etc. So now we have the posterized thing, and from that we could make our regions as always. And one of the regions maybe is actually this line here already. Yeah, let's get started with the next one already. Node regions. This node is posterized. Posterize. Nothing to update, but in a second there is. Yes. Why doesn't it remember this split point here? Oh. I don't know. Okay, regions, param, posterized, black and white image, and region, image to regions with diagonals, posterized, get. Could it be that easy? So we do our input ports here, do our output port here, we bring them close, we say magnetic connect, we get an error, yes, because the function has a slightly different signature. Yeah, this does the whole shebang. You only want actually to, we only want the last step. Only this, I guess. We can basically write it in one big expression. Make this worker object collect bounds. I think it does it automatically. With diagonals, let's set that to true, because that's the latest thing. And we just say get. And this is the actual name. Oh, okay. Not very good though. What if we'd have to get twice maybe? Nope, only once. Type 250, that's like it's an anonymous Java class. It should give us a list, actually. Aha, this is the anonymous object, which is only called 250. So let's give this an actual name. List from function. Yep. List from function A extends random access abstract list, etc. pp. And we can make it a record like this. I would like to make it final, but I don't think. No, it's fine. Oh, we need both versions, right? N first or F first. Here. And F for this function. Put the type there too. And like this. Functionality unchanged, but now it has an actual class name, which is a much better. Let's do one more improvement here. Compile main library. Is my input port not working? Should be though. Okay, list from function. Just why do we have 0 entries? That is not correct. Maybe the calculation is not actually even running. So it has this run method. I thought the get method. Oh, okay, you have to run it first and then get. Comma run, comma get. And that should be better. Error, okay, show me. Okay. Yeah, no. There we go. 15,000 regions. It's a busy image, including the webcam stuff. So we have our 50,000 images, regions. And we can check it out in our posterized version, which looks super clean. You know there's this gradient here. And the gradient turns out as, you know, just 2 regions with a clean line in between. Looks like a mountain, doesn't it? Nice little landscape. But, you know, the interesting line is just absolutely clean here. So we can follow it, and here it ends in, you know, there's no border here. It goes into this other shape. So we have to take that into account, but we can just say, as long as it is thin like this, we assume it's our, what do you call it? It's our graph. So I mean that should give us this graph. So we're looking for some mathematical property that distinguishes a graph like this from another thing like this down here, or whatever else we have. So what is it? What's the property? Property is a certain thickness, and it's usually not going vertical. If we have an extreme price jump, it could be look like vertical. Here it's almost vertical, but most of the time it's not. So most of the time it's going sideways or diagonal in some way. It doesn't loop back on itself, so it's not going in circles. It has only one value per x coordinate. So basically we go through these regions and quickly find out which one is a possible stock chart line. And then we write this down, all the coordinates, and so we can, in the next step, figure out what the time is and what the value is. And also, of course, we could read what the title is, and we could read the actual price right now and this percentage here. But our number and letter recognizer is not completely working yet. It's not yet working at all, really. So we should start with this here. So let's say we found the right region, then we have different options. We can go around the border of the region. That's one function, giving us the top boundary here and the lower one. Or we can just go through the pixels. All the pixels that are in the region. What's the actual size here? It looks like we have a thickness of 2 or something. There's anti-aliasing also. Which we can or cannot take into account. We could simply reduce the number of colors also. Let's say we have 4. That's equally clean, I guess. But now we have less of this anti-aliasing stuff going on. Did it actually change? 1, 2, 3, 4. That's not 4 colors, because if it was 4 colors, yeah, no, what? Okay. Okay. I put the 8 in there. Okay, try it again. Here, okay. So this line is still very clean, and actually we are lucky, and now this round thing has a different color. So our problem here has actually disappeared. It's often good to play with the number of colors and the resolution and everything, just to get a different perspective, and one of them is usually the best and works the best. Gives you the most direct access to whatever you're looking at. So there's still anti-aliasing, but it's only like 2 colors now. And we could get away with using only the darker one. Or we take the 2 at the same time. Or we reduce the colors even more. Eventually it might disappear because it's just green, and green is not black, so. How to proceed? We could go through the region and just note the highest and the lowest point. Yeah, that's actually pretty smart. Because the highest and lowest point are very close together in this kind of graph. Except, as I said, if you go very steep here. But that's the unusual case, so. And when it's steep, it is narrow. So. Yeah, why not? Let's go for it. 2 hours done. Good progress. Okay, param. Come on, try to type param regions. List of image regions. And we can already make our input ports. Oh, that's so cool. Move it to the right. Wow. Make output port. Move to the left. Connect. Wow. Do random calculation. Number of regions. Number of regions went down because we reduced the color count. Less colors means fewer regions. Obviously, proof is left for the reader or the viewer. So we have almost 6,000 regions, and we're trying to find out which one is our stock graph. So we go through them for region in regions. Wow. This is almost getting convenient. Find a graph line. We go through all the points. Pixel iterator. And we get max and min for each x coordinate. It's a range object, I guess. Int range, yes, that's what it is. An int range. Here, just start and end. Simple object. Int range, but I think this syntax doesn't work yet, does it? No, it does actually. Wow, cool. Get y min and y max per x coordinate. So we get this range, and with int ranges we can add things. Range add or range plus add range. This is with floating point. Let's make it with int range also. Int there. Oh, the int range class has start and end. The range class has min and max, so my naming is inconsistent. And I think it's also different in semantics. One is exclusive and one is inclusive. Yes, no, not DuckDuckGo. Oh man, I'm inconsistent. Yeah. Okay, whatever. So we add actually, yeah. Okay, if it's empty or this, make a new range. Here we do this. Actually, I don't want to overwrite the original object. If it's less than the minimum, we return this. And it's called start and end. If it's this, then we return that. Otherwise, we keep the range. I think it's correct. It compiles, so it has to be correct. Add to int range rpy, and we put it back into the list set. List put, I think. X that. Okay. Nice data flow. Okay. Okay. It's gonna make a huge data structure. Yes. Size. Yes. For every, yes. Okay. For every region, it makes this kind of list. But I wanted some scoring here. So it's a good candidate when first let's take the bounds, region bounds, and we shift it all to the left, meaning we only look at the area that's actually in the region. Get rid of all these nulls here. Is it calculating? These nulls should be disappearing. I'm pretty sure. Why are they still there? Huh? Calculating. Okay. Yeah, cool. So for each of the regions, this is we look at the leftmost column, and this is the range. So this one region, for example, is super tall. It's like the background or something. It goes from Y0 to Y900. It's a whole screen. And some others are only 1 pixel high. So let's just say we take the average. There should not be nulls in this list anymore, I think. I don't think. No, actually. So min max. We get the length of each range, heights, and let's say we get the average height, which is just the average of the heights. Int average. Yes. Okay, because the average height should be not 1, but smallish. I guess smallish will do. 2 or 3 or something, I guess. 4 or 5, but not more. Calculate, 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 calculate. Error. Okay. The range doesn't actually have a size function, it's called the length. Okay, yeah, so we have different heights. 3 point something, 1 and something. So let's say we sort this list. Okay, a lot of 1s, it will cut off after 1000 of these. And as I said, 1 is kind of a very boring graph. Also, we can use we can show the width of the thing. Pair height and let's say width of the region. Let's check that out. And it's time to speed up my language, because this should be faster. If this was Java, it would be faster. Okay, because many of these are just 1 pixel. These regions are just 1 pixel. It's super boring. So if area bounds continue area bounds if the area is 1, we continue. Non-nulls. Does this even work? I think. Wow. So now these should all disappear. Okay, now we have some small ones again. You know, if less than width, bounds width. Let's say something reasonable like 10. Skip it. Yeah. So the one we're looking for is actually super wide. It's like a couple hundred wide. So we could look at those. Yeah, of course, in the end, we want to have the system learn this automatically. Right now I'm doing manual filtering, but we will use like a simple perceptron thing that just learns that what the typical values are and filters accordingly. This is a very good candidate. So let's say maybe we have these pairs. Now we have pairs of average height, overall width. So let's say we sort by B minus A or something, or divided by. Let's say B minus A, why not? Sorted by calculated field. Pairs, and we have average height and width. We just say minus width minus average height. And in fact, we want the highest value first. And that may give us the correct region very near the top or at the top. Something like just a horizontal line will also appear. We have to filter that one out. Oh yeah. Oh, yes. Uh-huh. Okay, very interesting. Which one of these could it be? Interesting. Now we should visualize those actually. Mm-hmm. We have to preserve the region object so we actually know which one it was. And we have a sorted list. Apparently I can put as many closing curly braces as I want, and the language doesn't complain. That's maybe a bug. I mean, it's very tolerant, but possibly you can call that a bug. So we have sorted, and I wanted to show these regions in some way. Well, let's just output this. And then do some visualization. Okay, all good. Yeah, how do we show the regions, like which order they have? Okay, let's see, regions, analyze regions, pair. Yeah, this nested types don't work, although I could make them work. I mean, basically, let's make them work here. Nested types are a thing. Parameterized. Param. Param was nested parameterized type. Param x list of pair of int. Oh, okay, yeah. The symbol has three meanings. It's part of an assignment, it can be part of a type argument, and it can be this bracket-like thing for expressions. So here, do that. Do this like recursively. Parse type arguments. And also we have a comma there. I'm doing a lot at once here. Parameterized type. Okay. No, it's kind of complicated. Type arguments. Parse type. Do we have this yet? No. Parse type. Okay. Type parse type. Parse type. Okay. Oh yeah, it's not that hard. Rxed parse type. Closing brackets. And we need the comma too also. If closing break else consume comma. Yes. Yeah, I think that's it. Thankfully we have lots of test cases, so if I did anything wrong, we shall catch the error quickly. Hooray for test cases. I can make a very complex type signature here now. Actually, it's a list of pair, and this is another pair here. It's a pair of int, double int, so this is quite the signature. I even, yeah, 1, 2, 3, yes, I have all the closing brackets. Class not found int, yes, that is actually correct. Java X class shortcuts. That should go there. Int is short for integer. We could show the top regions in different colors. Just white for number 1, 90% gray for number 2, 80% for number 3, etc. So the 10th region would then be black and the rest is also black. It would be a simple way to display the most promising regions of the image. Yeah, sounds good. Once we found this graph, getting the actual value at each position is not hard. It's just the average y coordinate for each x coordinate. And that's all. We just have to interpret that in terms of the axes later to get the actual values. Okay, compiled okay. That's great. And we have done this before. Painting regions. I did this in my Webcam analysis spike. Yeah, we need some sorting here. Track objects in webcam. Networks. Show brightest regions. That should be the one. Here. Show best regions. Yeah, show probable stock graphs. This we don't need anymore. All the configuration, that's elegant. We can have pair here, pair region. Yeah, or whatever. Extract the region. Brightness, and brightness is for index. Do we have something like this? I forgot my own language. For index, I think. Yeah, I do. Well, see, for index IA. Super elegant. For index I region brightness is we start at 255. I don't know, let's do 16 brightness levels. Maximum 0 minus this this. If brightness is not 0, we paint. Error. What? Oh, the constructor doesn't actually exist. That's very possible. Yeah, it wants a width and a height, not just one value. Okay, okay, we're just not connected. We didn't make the input port. Here we didn't make the output port. Plus we didn't connect them. Here, connect, and now we should be better. Okay, image not found in pair. Image. Ay, check it out. Yeah, this is very white, meaning it's probably the first candidate. This is also very white, but definitely we can say, yeah, there's another criterion. I mean, the total height of the thing. There are easy ways to figure out that this is probably not the graph, but still it's very bright. I think the brightest region, actually, let's say we only show yeah, it's in the top 4, definitely, the graph. So once we have this graph, we can get all the values. Yeah, let's do a simple calculation. We take the lowest value, we take the highest value, and the current value, so we can get some kind of red-green statement. Price went up, price went down. That's pretty neat, isn't it? Let's do that. Yeah, let's make a different node here. Calculate price tendency. Note we still don't know which one the actual graph is, so we're doing this on a few other regions, and that some of them are probably going to give us a nonsensical result. Regions to look at, let's say we look at the top 4. We have pair of the region and our analysis. And the value in the beginning on the left. We need to store the full thing. We should make a class here, definitely. Let's make a class. Class analysis is ymin max. Bounds ymin max, and we have this average height double. So we make a new analysis object. A min max. Yeah, we can set it in the end. Analysis. A bounds is bounds. A ymin max is ymin max. Which height? There. No, it's everything is much more elegant. How about analyze the region? Put the region in there too. That's much better. Analyze region. A region is region. Analyze region. Minus width minus average height. That's how we did it. Okay, let's calculate. Okay. This one gives an error. That's expected, because our data structures changed, but the data structures are a lot better now. We don't really have the type is not visible there. It's the to do. I think this one should be fixed now. Yes, it is. Fine, that's good. Let's fix the next one. Okay. No, actually we don't need all of this. Take first regions to look at. We just take the first four for region, or analyze region, and add function I. No, not really. So we want the value on the left, so the initial value in the graph, which is just the first of this start range. Let's see what comes out. Nothing, because it's not connected. No, this was the wrong one. We need to connect up here. Yeah, okay. End range. Instead of range, we can actually just take the value center of range. Center. Yes. End range. Is it int or double? Let's make a new function, precise center. Precise center first, precise center last. Start y and y. And then all we need is the min and the max. Min y, that's pretty simple, that's just the bounds. And the other part of the bounds. So we have start, end, and we have max and min. And then we can make some kind of statement about the trend of this stock or crypto. So it's working hard here. Calculate price tendency. What's the matter here? Yes. Still calculating. Here, interesting. But we need to put some extra stuff in here. Okay. Okay, let's derive some text here. So max minus min is our range. Well, okay, and my if end is the same as start, then say price constant, else if end is greater than start, price down, else price up. Using up, constant up. So min and max. That's our full range. Like everything was, you know, highest point seen in the graph and lowest point. And we can express everything within that range, I guess. So started at, and we have start y, and we express that as part of the range. I do not think I have made a function for that. Shift scale. Yeah, okay. Relative to range. So we have a value and a range. We express the value relative to the range. Okay, double range is the one with the proper naming. We have range, double range, and int range. Double range is the good one, and range was the weird one. Should use double range instead. Double range R. So it's simply x minus start divided by the length of the range. Relative to range. This started closed at similar thing tendency Okay. My bad. Hey, we're almost at the 3-hour mark and I actually got the stuff done that I wanted. That's so cool. Tendency, and now we make a complete statement out of these 3 things. Started, closed, and tendency. Join with comma should serve as well. Okay. Yeah, okay. Of course, it's not very beautiful. Format 2% or whatever. Let's do some nice formatting. 100%. Yes, 100%. So one of these 4 is the actual one. Price constant does not look right. This graph definitely does not show as price constant. So that one goes out the window. One of the other 3 is the actual graph we want to see. Yeah, this one is taking too long. Needs optimization. It goes through all the pixels in all the regions, so it's fairly slow. Okay, here. Started at 99.7%. Oh, we are saying 100% is at the bottom. Yeah, let's do it the other way around, in fact. So we say -1, this -1. Here. I still don't know which one it is. If you look at the graph, it goes way up. So closed at 50%, that's wrong. If you look at this graph, this is 0 and the max here. It's not closing at 50%. Relative to the whole range, it's closing at very near the top. So this last one is the one actually. Started at 0.7%, closed at 88.4%, price up. So that's actually our correct analysis for the Monero price. That's pretty cool, right? Here. Let's make a screenshot and be very proud. Boom. Yeah, we still haven't had the machine figure out which one is correct, but this one is correct actually. So now we could run this on a live screenshot and always get the current price. Well, we don't have the exact price yet. We need to parse these numbers here. So maybe next time we can do digit parsing, digit recognition. Okay, that's great. 3 hours and I'm done. Cool. Bye bye.